Data and the data types. So data is recorded information. Data refers to recorded representations of the world via some means and material. Often you may hear different definitions of data, but this is the best definition of data in the way that people usually most often use the term data. And data is not raw. Usually, data is not raw, meaning without human input. All data, in the sense of data in the computers, the paper list of students who attended the class, the air pollution measurements on a chemical sensor, the database of doctors in your area, all of these data have been created by with some human input in their organization, in the focus on what they are to be captured, in how they are going to be captured, how they're going to be measured. Therefore, there is no data that is raw, and there's no data without information. All of data, in the sense of recorded data, is information already. There is no meaningless data. All data has some meaning. Now we can create additional meaning from the data, but all data have some meaning. And here are some examples of what we mean by data. It can be digital, it can be analog, but most of the time, certainly in the context of this class, we are talking about digital data. However, the source of that data may have been analog outside of the digital world. Often, when we're talking about data in the context of data analytics, we think of this high level distinction of structured, unstructured, and semi structured data. So, structured is data where records and fields are well modeled and organized, usually in a relational database or other formats like we will see, like JSON, JavaScript object notation. There is unstructured data, which is records and fields where the content is not well modeled. Fields are not, I'm sorry, here it should be, this is very important, not well modeled. That's the unstructured data. Structured, it is well modeled. Semi-structured is where data, some records or some content is well modeled and organized, but others are not. So the example of structured data is on the two-dimensional table that you're familiar with, the data frame of columns of attributes, rows of instances, and every cell usually has one single value. Sometimes you can see a long value here, a long piece of text, but usually we identify very specifically for index 0, payment type is Visa. Index 1, customer name is Bob, and so on. This is very structured data and very easy to work with for data analytical purposes. Now we also have unstructured data, which is data that is not well modeled and organized. So for example, a page of a newspaper or a digital news site, for example, like Bloomberg. Now, in a way, this data is organized because it's digital data, it's binary, it's organized in some kind of programming language or markup language. However, the data points are not really well structured in the sense of a database or a JSON file. So to analyze this data, we may need to retrieve, extract different kinds of content, different pieces of information, and then label it and organize it. Maybe we'll call this article title, and so on. So we think of this as unstructured data. So for example, even videos we consider often unstructured data, even images themselves. So here we know there's an image, but what is the image of? And nowadays there are methods and tools to analyze the image and structure the unstructured image, or better said, retrieve information from an image that is not annotated in any kind of digital way. So for example, we can apply a program to identify that this is a house with one door and one window. And that's a little bit about unstructured data, which can be structured And also there's semi-structured data, which is where some content is modeled and organized and some are not. So for example, a Twitter page, we have information here about the handle, the account name, the number of people following, the number of people that are being followed by this page, the number of people that this page is following. So this, some content is structured, some content is not structured, but then we have the message. So the full content of the message, we often would call this unstructured. So this would be like one piece of a field or one cell, but within that, this is not structured in the sense that it's ready for data analysis. But once again, we can structure the unstructured data and we can identify, so example, okay, so this is a hashtag, this is a company name, this is an organization, CDC. This is a verb. Receive is a verb. This is a medical treatment, booster shot, and so on. So we can structure unstructured data, and that's part of what we do in data analytics. Here I'm going to do a brief review of some data components that will be useful for us in this class, and you should already be familiar with this, so this should be serve as a review. Often when we're talking about data, we have some basic components that we need to be attentive to. So that's one is the individual observations. So these are the things being measured or the instances of the data. And when we're talking about table data, these are going to be the rows, right? And it's very important to know what the row is because it's not often immediately clear by just looking at the row. So you have to have understanding of the context, how the data was captured and things like that, or if the data was manipulated or aggregated in a certain way. So for example, if you're working in the context of bees and bees data, your unit of analysis may be a single bee, or it could be a colony of bees, or it could be a country that has bees. So it's very important to distinguish which one it is. Another important concept are the variables, of course, and these may be called dimensions or columns or features. Also a common name in data analytics, we call these the features. And then the values. The values can be text values or numeric values. And these are in the table format, these are the things inside the cells, the content inside the cells. Now, once again, it doesn't have to be a table format. We're going to be working with table and data frames a lot, but it can be also, data can be in format like JSON. So in the JSON format looks like this. We have key value pairs, key or also called name value pairs. So the name is the attribute. So for example, order number, and then here is the value. Order number, colon, is the value. Date is June. Tracking number is TN003. Customer ID is 11045, and so on. And notice how on just JSON format, we can have this nested content, which we do not have in relational database. So here we have a customer, all kinds of customer fields that are within the customer name here, and then also that is within the orders. So this is here all about orders. So this is one order, and we can have, theoretically, we can have more orders, and we have one orders, and then we have various name value pairs that can be nested. But the concept still holds. So this would be we think of this here as an attribute, and this is the value, and the observational unit is orders here. But also we can think of customers as maybe a potential unit of observation because the customer also has multiple attributes that can be analyzed. Another set of important considerations have to do with variable measurement and scale. Once again, this is a review, very important. So I'll go fast here and let you think about this if you need to review it more in depth. So we have different ways to measure the data. They can be nominal, and that's usually text, and it's the most qualitative way to think about data or measure the data. There's the ordinal, which is semi-quantitative. Can be some analytical process can be applied to it in terms of quantitative because it is semi-quantitative, but not entirely. So for example, poor, okay, and good. There's a direction. Maybe we can call this -1, 0, and 1. But it's only semi-quantitative. And then there's also the interval data, which is a quantitative measure, but without a real zero. Interval has no kind of real zero. For example, year observed. If we're talking about year zero, let's say when Jesus Christ when we started counting, the year zero is not a real, no year, it's not year zero, it's just um, it's kind of artificial zero. And then the ratio is a quantitative measure with a true zero, where, for example, years of age, if it has 0 years, that really means they have no years, but 1 is 1, and so on. And also we can use these decimal numbers as well. So interval often is related to integer as well, but not necessarily. We can have ratio and we can have ratios in interval data too. So it gets a little bit complicated, but this is the general types of scale measurements that we use. And also we have to think about the data types in the computer. For example, in the native language of Python, and this we should be able to translate these to data types. So for example, nominal data often is going to be called text, character, or string data type, depending on the programming language you're using. In Python, it's called string. Ordinal, which is the semi-quantitative variable, is usually going to be, well, it can be string, poor, okay, or good, or the data type can be integer, like we tested before, -1, 0, or 1. So this is an integer value. There's not a decimal. Now, the interval measure is integer, but I think technically interval, we could have a decimal here as well when we don't have a true zero, but that's a point for us to examine farther. And then the ratio. The ratio is the most advanced of them, in the sense that it's the most complex. We can have zero and we can have decimal, and the data type in the computer language might be called decimal, double, or float. In Python, we call this the float. So we're going to be working with float, integer, and string. Those are the basic ones, the native basic data types. And of course, binary. There's binary, which is true or false, yes or no. In Python, we're going to have true or false, or 1 or 0. If you have 1 or 0 in your data set in Python, that's usually going to be considered as integer, and true or false is a different data type. It's a binary data type. So think about that. And also remember how binary data, we can translate almost any kind of categorical data into binary. So for example, male, you can think of gender as nominal. Gender is male or female. But we can translate that to binary as, instead of the gender category or gender feature or attribute, we're actually going to have a male. So instead of calling it gender here, we're not going to call it gender, we're going to call male, and if it's male, we put 1, if it's not, we put 0. Now, of course, this cannot, it depends how many categories you have, but you can do male, and then you can do female, and 1 or 0. And you can also do other, if there are other genders, or you can say, no gender, and then 1 or 0, and so on. Next, we're going to be talking about the data set and the data frame.